Okay, the third and final form of a quadratic function that we're going to learn about is the intercept form of a quadratic function. So the intercept form is called intercept form because we can quickly determine the x-intercepts from this form of a graph. So this form is f of x equals a times x minus p times x minus q. So this form is factored form. So you may recognize when this is written out as factors. You might remember talking about factoring in Algebra 1. So remember that the coordinates of the x-intercepts, q0, I got interrupted and I don't remember where I was, but if we remember that the x-coordinates, or the way that the coordinates look like for x-intercepts, is that the y-coordinate is 0, and then we know the x value. So q0 and p0 is what we're going to refer to them as. A quadratic function is going to cross the x-axis either once, if the vertex is on the x-axis, twice, if it looks like this, or maybe not at all if it's, up here somewhere and it doesn't cross it any. So those are our options. So when it's in this factored form, then we can figure out what the x-intercepts are by setting the equation equal to 0. And so the values of p and q are going to tell us what the x-intercepts will be, always, okay? So that's what this first statement says. Because f of p equals 0 and f of q equals 0, then q and p are the x-intercepts of the graph of the function. What we're saying is if I plug in p here, then I would get p minus p, which is 0. So the whole thing is equal to 0. Or if I plug in q, I would get q minus q, and the whole thing would be equal to 0. That's what makes them the x-intercepts. So, ta-da, x-intercepts. The axis of symmetry is going to be halfway between the x-intercepts because the graph is symmetric. So to find the middle, we take the average. So we're going to figure out what the values of p and q are, and we're going to add them together. P plus q divided by 2. That's how we find the average. So the midpoint, that tells us what the x is. Now remember, the axis of symmetry is always at the x value of the vertex. So that's the x value of the vertex as well. And just like with all the other forms, if a is positive, the parabola opens up, and if a is negative, the parabola opens down. So here's how we find the vertex of the parabola in intercept form. Figure out what p and q are. Use the formula x equals p plus q over 2 to find the x value of the vertex. And then once we know the x value, we plug that back into the original function to find the y value of the vertex. Very similar to the process we used in standard form. Okay, so let's practice finding the vertex just to start. Also, one last thing. Remember that in the, as with all the other formulas we've worked on, the formulas have a negative in front of the p and the q, which means we want the opposite sign. Okay, so we have to flip the sign that we see to figure out what p and q really are. All right, so number 13. It says determine whether the parabola opens up or down, then give the vertex, x-intercepts, and the axis of symmetry. So number 13 says f of x equals negative x plus 1, x plus 5. So the first thing we need to decide is, does it open up or down? And we're going to tell by looking at the number that's in front of all the parentheses, what are we multiplying by? And that number, a in this case, is negative 1. So since it is negative, we know that this parabola opens down, okay? We want the values of p and q. So p is negative 1 and q is negative 5. Remember, we switch the signs. It doesn't matter which one is p and it doesn't matter which one is q. Those are our x-intercepts. You can list them as negative 1 and negative 5. It depends. Delta Math might be looking for them as ordered pairs. If that's the case, then the x-intercepts would be negative 1, 0 and negative 5, 0. Those are our x-intercepts. if they want them listed as a coordinate pair. It kind of depends on the system what they're asking for. Okay, so now to find the vertex, the rule is x equals p plus q divided by 2. We're just taking the average to find the middle. So in this case, that's going to be -1 plus -5 divided by 2, which is -6 divided by 2. So we get -3. Okay, that means our axis of symmetry is x equals -3. That's done. And now to find the vertex, okay, there's the axis of symmetry. Now to find the vertex, we're going to plug that in. So we want f of -3, which is going to be -3 plus 1 times -3 plus 5. This is all multiplication here. So -2 times +2. So that's going to be -4. So that is 4. And so what all of that tells us here now is that the vertex is -3. That was the x value. +4. So did we do it? Did we get them all? It opens down. Here's our x-intercepts, axis of symmetry, and vertex. That's all the things. So pause your video, and I want you to try the exact same thing for number 14. Okay, here's what I get. So A is 1/4, P is +6, and Q is -2. So since A is positive, the parabola opens up. Our x-intercepts are P and Q, so that's 6, 0, -2, 0. Average P and Q to get x, so I get x equals 2. That's the equation of our axis of symmetry. And then, well, I called this f, but I guess this function is really named g, isn't it? So g of 2 is going to give us the y value of the vertex. So I plug all that in, and I got -4. And so since the x-coordinate was 2 and the y-coordinate was -4, that tells us our vertex is 2, -4. Ta-da! There's all the things. Okay, now to graph these, it's really the same as what we did in standard form. So we're going to figure out P and Q. That gives us the x-intercepts. Those are 2 points on the graph, so that's what we need is 2 points. That's really helpful. So we can graph those. Then we're going to figure out the vertex. And as long as that gives us a good enough picture, then that's great. Now, sometimes that might be too close together, and sometimes there's only one x-intercept. If that's the case, then we might have to make a table, just like we did with standard form, to get some more points. But if those are far enough apart, then that's great. So let's look at number 15. So pause your video and do another practice run. See if you can come up with all of the pieces. So I want you to go ahead and decide, does it open up or down? Figure out your x-intercepts, the vertex, the axis of symmetry, and then stop and come back and check your answers there. So pause your video, find those parts, and then come back to me. Okay, so here are all of the pieces. We should get a parabola that opens down with x-intercepts at -3 and 1, and a vertex at -1, 8. Now let's go ahead and start with those three things, the two x-intercepts and the vertex. So the x-intercepts are going to be on the x-axis at -3, 0, so that's here, and +1, 0, so that's here. And then our vertex is at -1, +8, -1, +8. And that's definitely far enough apart that we can see what our graph is supposed to look like. So that's enough for us to get a parabola. That's all we need here for these graphs. Intercept form is really nice because a vertex and two x-intercepts, that's fantastic. Now, here's what I mean about it being too close together. If I get like a vertex that's here and two x-intercepts like this, that's really hard to tell like where my graph is supposed to go. That's really hard. So you might want to pick like another pair of points or something there. Especially if you only get one x-intercept, you're going to need more points to know what's happening there. So we might have to make a table and get a couple of values. Now that we have that, we can answer the rest of the question. So vertex, we've got axis of symmetry. We've got axis of symmetry is x equals -1. What else? Domain and range. Domain is always the same. Domain is all real numbers. The range is going to be y less than or equal to 8. Intervals of increase and decrease. Since this one is upside down, it increases first, then decreases. And remember, it always changes at that axis of symmetry. So it's going to increase when x is less than -1, and it's going to decrease when x is greater than -1. And there is all of our information. Let's try another one. I think this is the last one. Sure is. Number 16, y equals 4x times x plus 2. Now, this one is kind of weird because I don't see two sets of parentheses, but I do have two sets of multiplication. I have 4, which is my a value, and it's essentially 4 times x plus 2. So I can see that one of my values here is 0, either P or Q. Again, it doesn't matter which one. So I have my A value is 4. Let's say P equals 0 and Q is equal to -2. Sometimes my Q's look like G's. That was not a great Q. Let's try that again. I hate lowercase q. There we go. Okay, so let's go ahead and find the rest of this stuff. I'm going to do it quickly. Pause your video if you want, or you can go ahead and just copy it down after I do it. Okay, so there's my x-intercepts, my axis of symmetry, and my vertex. Let's plot those and see if that gives us enough of a picture to draw our graph. 0, 0 is one x-intercept. Let me pick a darker color here so you can see that a little better. There we go. -2, 0. Those are pretty close together. Let's see where our vertex is. -1, -4. That's probably far enough apart. So we can see this is going to be a really skinny parabola, and it should open up because A is positive. And 4 means that's a pretty good vertical stretch, so a tall, skinny parabola does kind of make sense. So there's that. Now we have domain, which is all real numbers, range, which is y greater than or equal to -4. This one decreases first, and it decreases when x is on the left of -1, and it increases when x is on the right of -1. And I do believe that that is all of the pieces. Now, what would the equation look like if there was only one x-intercept? This would be just to show you. It would be if a factor would repeat. So for example, if you had a squared factor, something like y equals -2 times x minus 4 squared. That would mean that I only have one x-intercept, and it would be at 4, because remember what that really means is that I have x minus 4, x minus 4. So that would mean P equals 4 and Q equals 4. So you could work with it that way. You would have to then make an XY table, just like we did when we did standard form, because that means that your x-intercepts is also going to be your vertex. So you're going to have to kind of treat it like vertex form if that's the case. Or like transformation form, vertex form. So just keep that in mind if that comes up, but it's not really intercept form if it's that way, so you shouldn't see that too much. So there you go. That is intercept form of a quadratic function.